Today we're starting activity 25 about arcs and central angles. This is lesson 25-1. Learning goals are to understand how to measure an arc of a circle and to use relationships among arcs and central angles to solve problems. Let's skip to page 2 of the notes and take a look at the definition of central angle. Here it is on the left side of the screen. A central angle is an angle whose vertex is at the center of a circle and whose sides are radii of the circle. The word radii is the plural of the word radius. An arc intercepted by a central angle is the minor arc that lies in the interior of the angle. So here we have a drawing over here on number 4. We have a circle. The center of the circle is point O. There's a radius drawn from O to A and another radius drawn from O to B. This acute angle in here is called a central angle. Notice that the endpoints of that central angle are on the circle, and connecting these two dots is a portion of the circle, a curved portion of the circle. That's a minor arc. So there's definitely a connection between a central angle and a minor arc. A minor arc is created from the sides of the central angle intersecting the circle, here at point A and at point B. This circle has a minor arc, arc AB, and the symbol for that is capital A, capital B, with a arc symbol or a little curve above. This is arc AB. There's only 2 letters in this name, so this is a minor arc. The circle has a major arc that also has one endpoint at A and one endpoint at B. Let me draw that in a different color. If we start at A and travel the other way around the circle, all the way until we get to point B, that is a major arc. It's much longer than the minor arc connecting A and B. To name a major arc, we're going to use 3 letters of the alphabet. We'll use the A and the B, but then in between them we'll put another dot on the circle that the arc goes through. In this case, point Q. And then put the arc symbol above the 3 letters, just this little curve. So we have here in red, minor arc AB, an arc that's less than 180 degrees. And then in blue ink, we have major arc AQB, an arc that measures more than 180 degrees. While we're looking at this drawing, let's also talk about the degree measurement of an arc in an angle. Let's make believe that central angle AOQ happens to be 45 degrees. Then the measure of minor arc AB is also 45 degrees. Notice that you could find the measure of the major arc by subtracting 45 from 360. Let's skip ahead to number 5 and try some practice problems. Given circle C, so notice the name of the circle is circle C. When you look at the drawing, C is the center, and so that tells us how you name a circle, by indicating its center. It has diameters, segment JR and segment KQ, and we're told that the measure of angle RCQ is 50 degrees. Let's label that. RCQ is 50 degrees. From that information, we can find all these answers. Question A, what is the measure of arc RQ? So if the central angle is 50, how much is the minor arc that's created from that central angle? It's 50 degrees also. Question B, what's the measure of arc JQ? So how much is it from J all the way over to Q? Well, notice that JR is a diameter of the circle. It cuts the circle in half. All the way from J to R is 180 degrees. What could you do with the 180 and the 50 to find JCQ? We get 130 degrees. Question C, what's the measure of angle CRQ? To find this, let's first create a segment that goes from R to Q. We're looking for the measure of that angle right inside this small triangle. Because CQ and CR are both radii of the circle, they're equal to each other. And because this triangle has two equal sides, it's an isosceles triangle. Its base angles are congruent. So the angle that I wrote this little arrow pointing into is the same size as this angle up here. All three angles of a triangle must add to 180. So what do both of these angles have to be? 50 plus 130 is 180. And that 130 has to be divided to make both of these angles. So 130 divided by 2 is 65 degrees. Angle CRQ is 65 degrees. Question D, let's find the measure of major arc JQR. Why did I say major arc? Because I saw that this arc name had 3 letters. So J through Q all the way to R. How many degrees is that arc? Well, it covers exactly half of a circle. It's 180 degrees. Question E, let's find the measure of major arc JKQ. So start at J, travel through K on the way to Q. How far is that? Well, it's not all the way around the circle back to J, but it is all the way around except for this amount in here. So a way to find our answer is to take 360 and subtract arc JQ. Well, earlier we had figured out that that was 130 degrees. So we can go 360 minus 130 to get our answer, and that is 230 degrees. Finally, question F says minor arc JK is congruent to what? Minor arc JK is from here to here, and that's going to be the same as arc QR from there to there. The reason is because these arcs are the same size as their respective central angles, and these two angles are congruent because they're vertical angles. So our answer is arc QR. The symbol for arc is a little curve on top of the 2 letters. Let's go to the check your understanding questions. Number 8. What do a vertex of a central angle and the center of a circle have in common? I'll pause the video for you to answer that. The answer is they're the same point. Over here on the side, let's make a quick sketch. Here's a circle. Here's the center of the circle, and here is a central angle. Notice that the vertex of the central angle is also the center of the circle. Question 9, what is another name for the sides of a central angle? In our drawing, what would you call that side there and that side there? And the answer is radii. They're both radii of the circle. Question 10, why is the major arc of a circle designated by 3 points on the circle? I'll pause the video for you to answer that. One way to answer is to say, because using 2 points would indicate a minor arc. Number 11, write the range of possible measures of a major arc as an inequality, and say why a major arc cannot be equal to 360. So a major arc is more than 180 degrees, but it's less than 360 degrees. A major arc can't equal 360 because then that's not an arc, that's the complete circle. So in this lesson, we learned about central angles and arcs. There are 2 kinds of arcs, a minor arc, which measures less than 180 degrees, and a major arc, which measures more than 180 but less than 360 degrees. A key idea to keep in mind is that the size of a central angle is equal to the size of the arc that it intercepts. For example, if we have this circle and have a 20-degree central angle, then this arc out here is also 20 degrees.